Hello and welcome to this video on R. Today we'll be going through some more statistical functions. Today we'll be learning how to test for normality, how to test for equality of variance, as well as how to test for equality of means. So let's begin. First, let's look at how to test for normality. So in this case, I have a data frame, we'll call it DF3. And I have specifically identified certain variables: car, minivan, SUV, and truck according to this column of vehicle driven. I want to test whether the miles driven per week within each category of whether it's a minivan, car, SUV, or truck, whether the miles driven is normal or not. So I can use something called the Shapiro test. So go Shapiro.test. Beginning with car, I will have C miles driven per week, and this is what I have: p-value 0.07. This means that at the 5% significance level, I will fail to reject the null hypothesis and conclude that the miles driven per week by cars is normally distributed. So what exactly did I say? As you can see, the p-value is 0.07 and I compared it to 0.05. Why 0.05? It's because I said at the 5% significance level. So there are different levels of significance. This means, in a sense, a different threshold. So usually at the 5% level of significance, I will compare my p-value to 0.05. If I say 10% level of significance, I will compare my p-value to 0.1. If I say 1% significance, I will compare it to 0.01. The null hypothesis in the Shapiro test would be that this variable that I have here is normally distributed. So if my p-value is less than 0.05, supposing I'm at the 5% significance level, I would have enough grounds for me to reject my null hypothesis and accept the alternate hypothesis that the miles driven per week by cars is not normally distributed. In this case, it is more than 0.05, but let me give you another example. Let's look at SUVs, alright. Miles driven per week. And yep, we have a p-value that is less than 0.05, I have 0.03614, which means that at the 5% level of significance, I have enough grounds for me to conclude the miles driven per week by SUVs is not normally distributed. Now on to the next part. Let's look at how to test for equality of variance. Now there are a few different tests for equality of variance, as we have here F-test, Bartlett test, Levene test, and Flenier test. So to start, in fact, we have F-test that is arguably a subset of the Bartlett test. What do I mean by this? The F-test is used for only 2 samples, whereas the Bartlett test will allow for 2 or more samples. Now, as for the Bartlett test, it is used usually when all groups are drawn from normal distributions. Levene's test is usually used for normal distributions, but it can tolerate some deviations from normality. Flenier's test is used when groups are not normally distributed. For instance, I could have the Bartlett test, Bartlett.test, and perhaps maybe let's look at miles driven per week. And I'm comparing it to the vehicle that's driven. Now, as you can see, my first variable that I will have here is something ordinal or numerical. My next variable will be something that is categorical. So now I have a p-value of 0.002264, which is less than 0.05, which means that at the 5% level of significance, I can reject the null hypothesis. Now again, the null hypothesis in this case is that the variance are equal. So at the 5% level of significance, since the p-value is less than 0.05, I will reject the null hypothesis and conclude that the variances are not equal. Now let's try another example. This time, let's try the Levene test. Now, in order to do the Levene test, we need to call this package called car. Now let's try the Levene test. For the same miles driven per week. Now again in this, we can see that our p-value is actually this probability that's over here. Since the probability is more than 0.05, we will fail to reject the null hypothesis because we do not have enough grounds to conclude that there is no homogeneity of variance. In other words, we believe that the variances are equal at the 5% level of significance. So the linear test works in a very similar way. We'll skip that for now and we'll go on to the next part, which is test for the equality of means. We have something called the ANOVA test. Now in this case, I'm just going to test for the miles driven per week, and I'm going to compare it among the vehicles driven. So we'll start by just defining this variable. Next we get a summary of this. Now again, you can see it, the probability here. At the 5% level of significance, you can see that it is less than 0.05, which gives us sufficient grounds. In other words, we can reject the null hypothesis that the means are equal and conclude that the means are not equal. For the means to be equal, all of the means in every category, truck, SUV, car, and minivan, must be equal as long as one of them is not equal to the rest of the groups. This probability will be something that's low. So in order to use this ANOVA function, the variable must be normally distributed and the variances of the groups must be equal. But even if it is not normal, ANOVA test can still be used because it is fairly robust to test for departure of normality. Now, if the variance is not equal, you can use the Kruskal test. Yep, with that, we thank you for your attention. We'll see you again.